about cracking the foundation, attacking Windows Communication Foundation web services. So my name is Brian Holyfield. I'm one of the co-founders of Gotham Digital Science. We're a security consulting firm that really does a lot of software security testing. So really the background for this talk was that we're starting to see a lot more applications that use WCF for talking to either clients or web clients or even other web services. And there's really a lot of gotchas when you're looking at a WCF web service that if you don't really understand can really cause you to stumble when you're trying to break one of these services. So the objective is really to go over just quickly some key concepts around WCF so that you're familiar with them, and then really talk about different techniques, different tools, different things you'll need to know for attacking and testing these services. So I'll spend a little bit of time very quickly on an overview of just a couple key things. Then we'll talk about metadata, which is, like any web service, getting your metadata is one of the critical steps if you're going to want to then start probing and attacking the different methods that it exposes. And then we'll talk about manipulating endpoints. We probably won't have time to talk about custom clients just because we started a little bit late, but if we have time, I've got some material on that as well. So, kind of taking a step back, WCF is really the predominant framework, communications framework that Microsoft is really encouraging developers to use for all network communications. So it's been around since .NET 3. They really made a bunch of enhancements in 3.5. They're continuing to make enhancements even with the newly released 4.0 framework. And really the key here is that there's a bunch of different protocols and message formatting options that WCF supports, which really renders a lot of the tools that are out there a bit useless when it comes to from a testing perspective. So this is just a quick overview of the different legacy mechanisms that .NET or Windows has for communicating with different systems. They've pretty much all been superseded by WCF. So there's really three key things that you need to know about any given WCF endpoint that you're going to attack. So just like any other web service, you typically refer to the exposed endpoint, and there's what they call the ABCs of a given endpoint: the address, the binding, and the contract. The address is fairly straightforward. It's in a format that you're probably familiar with: the transport with the colon forward, 2 forward slashes, the machine name, if there's a port number, and then an optional URI as well. A lot of times if you're looking at a web server that's hosting one of these services, the real easy way to tell if this is a WCF service, historically .NET web services have a .asmx web file extension. The WCF services have a .svc file extension. They don't have to, but more often than not they do. The most important thing you need to know is the binding. And the binding really dictates the transport protocol that the web service requires to talk to it, and also the format of the messages that it's expecting to receive and that it's going to send you. And there's a whole bunch of different bindings that come out of the box, and then they even give you the option to customize a binding, so you can really have any combination of these transport protocols and encoding formats. I think if you were to really focus on a subset of them, you're normally going to see either HTTP or HTTPS as the network transport, or net.tcp, which is a pure binary protocol that's a proprietary WCF network protocol. And then down at the message level, you're either going to have, again, they've got an optimized binary format that's meant for transport between two WCF or two Microsoft technologies. And then, of course, there's the standard text-based formats like SOAP, XML, JSON, that type of thing. And then the last thing is the contract. The contract really just dictates the different methods that are exposed. At the end of the day, you really have no control over the contract. The developer has dictated this. So the only thing to note here is that by default, they've really tried to take a secure by default approach, and there's nothing that's included in a contract by default. Every method needs to be explicitly included in a service contract. So the developer, it's difficult if they're at least crafting these classes by hand to really inadvertently expose different methods. So moving on to the more relevant stuff here, The first step in attacking any given service is doing a little reconnaissance and obtaining some metadata. So thinking back to your classic web services, normally you get a WSDL, and you can do that with, if support for legacy WSDL is enabled on the endpoint, you can append just a question mark WSDL, it'll spit back the WSDL. The preferred mechanism for exchanging this metadata is known as MEX, which is the metadata exchange format. That's actually a W3C spec that's currently, I'm not sure if it's still in draft or not, but this is really a protocol that's designed specifically for exchanging metadata. It's the exact same type of metadata that you would get through the WSDL. It's just a slightly different way to get it. So again, out of the box, they've really tried to take this secure approach, and whereas previously the WSDLs were published automatically, you had to sort of disable that. By default, no metadata is published with WCF. So that's sort of the bad news from the attacker's perspective. The good news, however, is that if the developer is using Visual Studio, which 99% of the time they're going to, it's going to generate a web.config template for the developer, and the metadata is enabled in that template. So if they're using Visual Studio, chances are they're going to have metadata enabled unless they've gone through and actually deleted this area. You can even see where in the default template it tells you to avoid disclosing metadata, you'll want to back this setting off. So this is what a typical, the helper page looks like if you were to make a GET request to one of these endpoints. Very similar to the legacy helper page, with the exception that doesn't actually give you the list of methods that you can drill down to. It just gives you the URL where you can obtain metadata. Now there's a couple things to note here. The first is that in that default Visual Studio template, they've enabled metadata for HTTP, as you can see with the HTTP GET enabled, but they have not enabled metadata over HTTPS. So the WCF framework actually will not publish metadata if it hasn't been specifically allowed over either HTTP or HTTPS, depending on which protocol you're using. So you can see here, this is an example of a helper page that there's a couple differences here. The first is that we're accessing this over HTTPS, even though this is actually routing internally to a web server over HTTP. So this is probably using some sort of SSL accelerator. If that's the case, we may or may not be able to get the metadata here. You'll also notice that the host name is different, and that's because the endpoint's going to actually publish the local Windows host name of that device. So if you're trying to obtain metadata and it's not working, those are a couple quick things to pay attention to, is whether the protocol is right and whether the host name is right. And you can easily use one of those intercepting proxies like Burp to just do a find and replace on the protocol and the host name, and take off that additional port as well. So I mentioned before that obtaining metadata through MEX is fairly straightforward. It's just going to take a slightly different request structure. And the way you do that typically is through a post request to the endpoint, followed with the developer has to explicitly include the path to the MEX endpoint. So in this case, it's /MEX. That's the default one that Visual Studio creates. So again, in virtually every time I've run into a WCF web service, it publishes metadata with a /MEX endpoint. So if that's the case, this is pretty much the request that you would use to get that information. There's really only two pieces that I've highlighted there that you're going to need to change from the verbatim example that we've got here, not including the host header, if this is a virtual host. So it's pretty straightforward, and again, that's going to dump the WSDL right back at you. Another option for obtaining metadata, which is a newer option that's only supported in version 4 of the framework that just came out, is what's called WS Discovery. This is actually, again, another standard for dynamic discovery of endpoints on a network. It's an open protocol, and there's really two models that you can use WS Discovery. In any case, it all operates over UDP, and what happens is, as a web service comes up on the network or goes down on the network, it actually announces itself through hello and goodbye messages that broadcast over UDP to the local subnet. And then all of the other, if this is running in ad hoc mode, all of the web services are listening for these hello and goodbye messages. They can also send a probe request looking for web services on that subnet. The only difference between ad hoc and managed mode is that in managed mode, there's actually a central directory server that's used to record all of these hello and goodbye announcements and service all of the probe and resolve requests. So this is something that you may not be able to use over the internet, specifically because it's typically meant for just local subnet discovery, but certainly on an internal network, or depending on the scenario, this could come in handy to know. And I haven't seen this really used at all, but that's, again, the version 4 of the framework just came out of beta less than a month ago. So this may be something we see down the road. So that's sort of the basics of obtaining metadata. The real, the key to attacking these web servers is not so much getting the metadata. In some cases it is, but really understanding how to talk and manipulate to these different endpoints. So I'm going to run through 3 scenarios, and I've got a demo lined up for each scenario. Hopefully, time permitting, we can get through all of them. The first is going to be a Silverlight client service that consumes a WCF web service. The second scenario is going to be just some quirky stuff around what's called the WCF duplex bindings. And then the third scenario is using WS security, which is the web service security standard that allows for things like message encryption and so forth. So the first scenario is a Silverlight client service. Starting with Silverlight version 3, there's pretty good support for WCF out of the box. If you're in Visual Studio and you're creating a Silverlight project that needs to consume a web service, or if you're creating a WCF RIA service, it's automatically going to use a custom binding that goes over HTTP or HTTPS, but uses the binary message encoding. And the way you can tell that you're looking at a binary message encoding, other than the fact that it's going to look like garbage if you see it in a packet sniffer or in a proxy server, is through the content type header. You're going to have either MSBin1 or SOAP MSBin1. It's essentially, the only difference here is there's 2 different proprietary protocols that they're using. One is just binary XML, the other one's binary SOAP. They have published the specs. You can Google the spec, and on MSDN they've actually published the spec for it. But it is a proprietary protocol, so that's not to say that spec can't change from version to version. So if we look at our vanilla use case here, typically most of us that are familiar with attacking some web-based applications are going to use something like an intercept proxy, like Burp, for example, to intercept all the data between the client and the service. So the problem that we're going to encounter here is that Burp does not support this binary message encoding. It's very similar to if you're testing a Flex application and they're doing the flash remoting stuff. The message body is going to end up being binary, and if you try to edit it, it's not going to be serialized properly, and it's going to cause the other side to choke. So I'm just going to show you an example of what this looks like in a browser. This is just a sample application that I've got here with a login page. This is Silverlight. I'm going to go ahead and enable, and the screen resolution is really small on here, so hopefully you'll be able to see. The good news is I'm running the same resolution here, so I'll be able to tell if you can't see it. I'm going to point it towards a Burp proxy, and I'm just going to go ahead and try to log in with the username and password and hit the submit button here. And what's going to happen is, again, it's kind of hard to see at the bottom here, but this is actually the message body. You can actually see some text in there. However, you'll see some non-printable characters here. And if I actually try to edit this, so let's say I try to, let me just go to here we go, much better view. If I try to go and change the password that I entered in here, and then I forward it to the web service, what's going to happen is I'm actually going to get I get a 200, but you can see here I've got a formatting exception that gets thrown here because it wasn't able to deserialize that message. So this is the first major problem you're going to encounter here, is that you can't edit any of the values that are going back and forth here with most of the proxies out there. Now, initially I did some research into looking at different options for this, and it turns out that Fiddler, which is another fairly popular intercepting proxy for Microsoft that runs on Windows does have two inspectors, which is kind of their version of a plugin, that support binary XML. The problem is they're both read-only. So while you can view the data, it'll deserialize the message, you can't actually change the message. And I'm not an expert on Fiddler, but I contacted one of the guys that wrote one of these inspectors, and they seemed to think that, or they told me that it was a limitation of the Fiddler API, that it can only do read-only. So I'm not sure if that's a limitation of Fiddler or not. But the long and short of it is that this may make it easier to read that data, but you can't change it. And from an attack perspective, that's not very useful. So the only solution for this was really just to whip something up to fix the issue. Burp, as you know, has a pluggable architecture. So I created a Burp plugin that essentially just intercepts these requests looking at the content type and then hands it off to a .NET DLL that actually deserializes that data, shows it to us, and then reserializes it and passes it off to the web service. Those of you interested in Burp, those are the different the interface hooks that the plugin uses. The plugin's available for free download on our website along with the source code. Just to give you an example of what it would look like, that same exact request that we just issued, you can see here, you got a timeout because I didn't forward the response. But if I go ahead and switch this over to a second instance of Burp running on 8282 with the plugin running, and I'll go ahead and resubmit, just make sure intercept is on. I'll go ahead and resubmit that login request. And what you'll have here is you can actually see this is now, this specific endpoint is using binary XML. So you can see we've deserialized it and it's regular just plain XML now that I can actually clearly read the different elements and the values there and edit them as well and forward that off to the web service. And what's going to happen here is you'll notice that the response is still binary, and I'll talk about why in a second. But once I forward that on to the Silverlight client, it tells me username or password is incorrect. So this now gives us the ability to edit that data on the fly. So we've now sort of eliminated that binary message format as an obstacle for manipulating this traffic. Now, just a side note, you'll notice there that the response was still binary. The reason for this is that if you look at the two hooks that we're using on the Burp interface to do our encoding and decoding, one of them gets invoked before you edit the request. The other one gets invoked when you after you edit it. The difference is on the way back, they both hit before you edit and not after. And this, again, it's a limitation of the Burp API. I've emailed back and forth with the guy that wrote Burp. He's definitely aware of this issue and has sort of roadmapped this as adding another interface method to re-encode data on the way back to the browser. But for now, the only workaround is to just chain two of these proxies together. So what you can do is you can just chain two instances of Burp together. One will intercept and decode the requests, the other one will intercept and decode the responses, and then between the two, you'll have the ability to edit responses. The only real reason you'd need to edit a response is just to maybe to trick the Silverlight client into doing something, enabling a button or something like that. Or in some cases, as you'll see in a few minutes, sometimes if you have a lot of that binary data, it's hard to read. So there could be situations where you want to do this. That's the only workaround I know of at this point, but it is effective. So another thing to be aware of with respect to WCF, and especially when it comes to Silverlight, is there's a new sort of framework that's come out that Microsoft has released called RIA Data Services. It used to be .NET RIA Data Services. Now it's WCF RIA Data Services. Essentially, all this is, it's sort of a rapid development framework for building rich Silverlight applications. And specifically the RIA data service component actually allows the developer to very easily expose the data access layer to the Silverlight client through web services, specifically through WCF services. And they call these domain service classes. So this is sort of the GUI that you get in Visual Studio. And one of the themes I think that you'll see when you start looking at a lot of this stuff is that while Microsoft has done a lot to really make sure everything is locked down by default, so you write a vanilla class, by default the class doesn't expose anything, there's nothing turned on by default. However, Visual Studio automatically turns everything on by default. So it's, to some extent, they've come a long way in making sure things are secure by default, but then they've sort of undone a lot of that because Visual Studio makes it so easy to turn all this stuff back on, and actually, in many cases, it's on by default. So if you were to take one of your .NET data entities within Visual Studio and you want to expose it to the Silverlight client, all you do is you create one of these domain service classes. By default, the Enable Client Access checkbox is turned on, so that means it's remotely accessible. There's an option there that says Enable Editing. So by default, this is not actually checked, but by default, it'll expose a method to dump the results of any given table or series of tables out to the client. When you check off the Enable Editing box, it actually generates methods to create, update, and delete all of those entities as well. And again, unfortunately, there's no authentication by default, there's no authorization by default, and it doesn't specify whether you want to do create or update or delete. It does all create, update, and delete. It's up to the developer to then dive in and specifically disable all of those unnecessary methods if they don't intend for users to access them, as well as enforcing any sort of authorization authentication. So I think this is a really good example of where the GUI-driven development makes it very easy for somebody to shoot themselves in the foot and inadvertently expose full create, update, delete access to a bunch of back-end tables that they may not actually realize they're doing. So a couple points to note here on RIA data services. The interesting thing is the way that these services work is it actually uses an HTTP module that gets installed within the web.config that automatically creates sort of virtual endpoints. So the good news is that metadata is not exposed, so it doesn't turn on the WSDL, it doesn't allow MEX requests by default. And it creates these virtual endpoints that are somewhat hard to find if you don't know they're there. The .svc file is not on the file system. It's not defined in the web.config file. The module is dynamically doing this at runtime based off some auto-generated classes. So it makes it very hard to find these things if you don't know they're actually there. The other thing to keep in mind is that if you see the submit changes method, this is the method that gets automatically created when you check that enable editing box off. So as soon as you have that submit changes method there, you can potentially create, update, and delete all the data that the service is exposing, depending on whether they've gone the extra mile and enforced any sort of restrictions on that. So I mentioned before that the good news, at least from a security, or the bad news to the attacker is that under this scenario, you don't have metadata. So if you're trying to attack a web service, you're really dependent on figuring out the different methods that are exposed based off of using something like the Silverlight client. So the good news is that you can easily decompile that client, and whether they're using all of the different methods or not, unless they've specifically stripped some of the interfaces out of the ZAP file or the XAP file, which is the Silverlight file, all of the interface methods are going to be in there, and it's going to give you essentially all the same data that you would have normally gotten through the WSDL. It's just going to be a little bit harder to find. So I'm going to show you quickly how you would do that. This is actually an application that was written with the RIA data services. So if I actually just do a view source on this page, and I go down to the find out where the actual ZAP file is embedded here, and you can see it's right over here. So I'm going to go ahead and copy that into my browser, and it's going to prompt me to download the file. I'll just download it to my desktop. It's already there, but download it again. And luckily, the ZAP file is nothing more than a zip file, and the zip file includes all of the different .NET binaries that the Silverlight runtime needs to actually run the application. So I'm going to go ahead and just extract all of these files to a folder here. Just give me a second. The machine's I'm running 2 VMs for these demos, so the machine is a little bit sluggish. I'm going to go ahead and just extract this to a folder. It's already there, but I'll just overwrite it. And then what happens here is in this folder, this is the contents of the ZAP file. You can see it's basically just a bunch of DLLs and a manifest. And if you were to open any of these DLLs in .NET Reflector, all of the system.windows and system.service DLLs, those are just standard DLLs. They're not going to be interesting. This HR app is really the custom DLL that you're probably going to be most interested in. So if we actually go through and we start browsing this, I'm personally not a big fan of browsing code in Reflector. It's not the easiest to use interface. And it's kind of hard to dig around in the code. So normally the first thing I do is I just highlight the entire DLL and I'll do an export. And that'll actually just disassemble the entire project to a folder into whatever language you want. I've got C# enabled here. And it'll even go so far as to generate a Visual Studio project file. So you can actually open up the code just as if you were looking at it in Visual Studio. So if I go ahead and open up the project file here, I think I may need to convert it because I think it does an older version of Visual Studio, but that's certainly not an issue. Once we convert it, you can actually start browsing through the source code and really digging around and looking at the different classes that are in here. One of the tips that I'll normally recommend is look for anything that's using the system.service model class. So domain services, the domain service client is the RIA client. The service model, the regular service model client is just going to be for any other type of web services. This is normally going to be, and again I apologize for the resolution, this is going to be the class that has all of your different interface methods for the web service. So you can see here that it actually declares a URI that includes the path to our SVC file. So immediately now we've already got, think about where we were a minute ago where all I was able to do was invoke that login mechanism, and I knew that that login service was there, which if I go back to our burp log here, it's basically the authentication service. There's actually several other services back there as well. This is an organization service. And then what you'll want to do is actually scroll down. Eventually you should probably find just an interface that has all of the different methods defined. So here, for example, I can see there's a getEmployees method that's exposed right here. You can see here that it looks like they even allow web gets to this method. So if I actually just plug that in, and I've already got it lined up here in burp repeater, if you actually go to, if I just go ahead and plug in the organization service instead of the authentication service, and I change the method to getEmployees, and I'm doing a get here, and I just hit go, what's going to happen is, it doesn't even matter what's here. This is actually, if you look down at the request body, that's actually the request body from my login request. I'm just doing a vanilla get to this method, and again, I'm not even sure if you can see it here because of the screen resolution, but you can see the OK, and let me just try to copy and paste this all to a text file. Well, there's a lot more in there than just that. If I'm scrolling, you can only see one line at a time. I apologize for that. I'm not really sure how else I can get this to render. But essentially what's happened here is this getEmployees method, as I mentioned before, when you're creating these RIA services, all you have to do is check a box and it's dynamically going to generate a virtual endpoint. And unless the developer goes through and adds an attribute to every single service that says this service is authenticated, requires authentication, you may be able to just anonymously invoke some of these services and pull out data. This actually dumps out a list of all the employees in that application. Another thing to keep an eye out for as well is I mentioned that submit changes method. If that's defined, that means they've checked that box that says allow, make this interface or make this service editable, in which case now you can potentially do creates, updates, and deletes. So the bottom line here is that even though you don't have metadata exposed by default with an RIA service, you're normally going to have a ZAP file, and that ZAP file is going to give you all the information you need. So just some pointers there. Look for system.service model in your decompiled code, and also look for the service contract attribute, which is normally going to be on top of your interface. And that'll basically just give you a list of all the different methods that you can call. So that's scenario one, which is Silverlight. And I think that's going to be clearly, if you're looking at client-facing, customer-facing applications, that's going to be your number one scenario. There's some other scenarios that you may only see between B2B or app-to-app sort of environments that are certainly worth pointing out. The first one here is what's called a duplex bindings. And this is really just an interesting thing that I happened to stumble into when I was looking at the different bindings. There's one binding in particular. So duplex bindings are bindings that allow two-way communication. So think about your normal web service is basically just a series of requests and responses between a client and a server. In a duplex binding, the service actually has the ability to push data real-time back down to the client. So there's a bunch of different bindings that support two-way communication. One of them in particular operates over HTTP. And the reason this is interesting is if you think about HTTP, it's really a one-way protocol. So the only way to establish two-way communication other than some sort of a polling mechanism, which there is another binding that does polling, this one actually opens up a callback channel on the client machine, and that callback channel is used by the server to push data back down to the client on the receiving end. So this isn't something that's going to work through a firewall, but for some reason apparently there's scenarios out there where potentially this is going to be useful. So they've defined a binding for this. Now, again, the real interesting point here is that the receiving end, the client, actually opens up a listening port that has almost a lightweight web server running on it. It uses the HTTP API, which is the same API that IIS-7 uses. And the way it works is the client actually informs the server of its URL and its host name. Its URL and its port number, and then the server acknowledges that by sending an acknowledgement request back to the client. And once that happens, the two-way communication starts. So there's something really weird or interesting, I should say, that happens here. This is just a vanilla use case. This is sort of the intended use case. The client initially makes its request to the service. It basically makes a create sequence request, which you can see there in the action, and it tells the service where to reply to. So it says, okay, reply to me on port 8000 at my host name. The service is then going to send an acknowledgement request. It's basically a create sequence response request back to the client on that port and to that URL and to that port, and then it's going to send an accepted message back as the response to the original create sequence request. And then if all goes well, the client's going to send an accepted response back to the service, and at this point, sort of a handshake has occurred, and the two-way communication begins. So that's sort of the intended use case. The important thing here, again, is that we've got two different sessions going on. One between the client and server over port 80, the other between the server and the client over port 8000. Now let's look at a different scenario. This involves two machines or three machines, a client, the same service, and then a machine we'll call target. So the client sends its create sequence request to the service, except this time, if you'll notice in the reply to address, it says reply to target on port 8000. So what the service is going to do is it's going to send that create sequence response to the target on port 8000. It's then going to send back the client an accepted message. And then the target obviously didn't solicit this request, so it's just gonna be like, you know, what's going on here? Chances are that port's not even open. So in most cases, this is gonna time out, or it's gonna just it's gonna get a reset because the port was closed. So building on this scenario, let's say we have two targets. If we do that exact same thing, we issue our create sequence request to target 1. Target 1 gets this request from the service that it didn't ask for. The service sends us back an accepted response. Now let's say we follow it up with a second create service request to target 2. Well, interestingly, nothing here is going to happen. Whoops. Sorry about that. I just hit the end button. Okay, so we send our create sequence request to target 1. It sends the request to target 1, sends us back an accepted. We're going to go ahead and follow up with a second request, create sequence request to target 2. Nothing is actually going to happen here until that timeout occurs. Only after that timeout occurs is the service going to then send that second create sequence request to target 2 and send us back an accepted message. And then, of course, that's going to time out as well. So the key part of this whole thing is that nothing happened on that second request until that first request timed out. So what we can do here is we can actually enumerate the state of the previous request based off of that delay that the server has in responding to us when we issue a follow-up create sequence request. So what we can do is we can use this time delay to actually figure out whether the previous connection was successful or not. So what we did here is sort of a proof of concept is we figured out that this can be an effective way to sort of port scan a machine using this delay to figure out whether the port was open or not. So if you look at a typical, this is an actual create sequence request. The important point here is this reply to address, and that's going to be the machine that you want the service to try and connect to. So what we'll do is I'll show you a quick example of what that looks like in Repeater. I've got an actual duplex web service running on one of our VMs. So I'm going to have it connect to the local host on port 88. I'm connecting to the to that same host on port 88, so I know that there's a web server listening. Again, this is kind of hard to see, but really, as long as you see that line down here, the accepted, that's really all that matters. So if I go ahead and issue this request, you can see that the accepted message comes back pretty quickly. I can do another one, comes back pretty quickly. I can do another one, it's going to come back pretty quickly. Now, if I actually do a bogus host name here that won't resolve, I'll send that request in, comes back pretty quick. I send a second request, and you can see that it doesn't actually come back that quick. And the reason for that is that the service is trying to resolve the host name that I just asked it to connect to previously, and until that resolve request times out, it's not going to even think about processing this request. So first we can actually connect to other machines. We can also connect to different ports on this same machine.
So is it the host resolution that's timing out, or is it actually...
In this case, it's the host resolution. What I can do now is, let's go back to localhost, and I'll go back to port 88, and let's just make sure that our connections are happening here. Now what I can do is I can say connect to 89. The first one comes back. The second one, it's hard to tell here, but it came back a little slower. If I actually go to 135, you can see that now it's actually hanging, because if you try to connect over HTTP to port 135, it kind of just hangs until the Windows, then BIOS server sort of chokes, at which point this will come back. So rather than just sort of do this haphazardly manually, we figured this really was probably worthy of automating to really figure out how effective this is. So what we did was we created a port scanner that essentially does this exact same thing in an automated fashion, connecting to any web service that uses this binding. The nice thing is it works behind a firewall, so if we want to try and probe machines in the same DMZ, we can. And it's a little slow, but it's effective. So you can see what happens is the first probe, really, we don't care about the response time. It's only the second probe that tells us the response time from the first probe, and so on and so forth. So as an environment to do our test, we actually used the Microsoft Azure cloud service. And we didn't know this at the time, but as it turns out, this was actually a perfect environment to do a test, because if you look at the way the Azure cloud infrastructure is designed, all of the VMs are actually on a private 10.0 network. And those are NATed inbound to externally resolvable IPs based off the customer and what VMs they're using. So if I have myapp.cloudapp.net, that maps internally to one of those 10 dots, those VMs on the 10.0 network. So the way the tool runs is it has two options. One, you can just probe a single host in a range of ports on a single host. The other one is you can probe multiple hosts on the same port. And if we look at the results of what happened when we first ran this on our cloud app, we knew that our machine was on the 10.115.213 subnet. We knew that just because we uploaded some code that would echo out the IP address. And if you do this, we actually scanned all the machines on that subnet on port 20,000. The reason we picked 20,000 was that also based off our testing, we knew that IIS on the VMs, for some reason they don't run it on port 80, they run it on port 20,000. So we wanted to see what other VMs on that subnet had IIS running. And you can see here that all the responses either took greater than 7 seconds or less than 0.2 seconds. So using that, we're able to infer what machines have that port open. We actually confirmed this by uploading FSCAN to the box and running a scan against those machines as well, just to confirm that the results were the same. By that same token, we also scanned our local host. We just picked a small range right around the terminal services port, so 3387 to 3393. And as you can see here, all those response times, again, they were either about 1.1 seconds or less than, or they time out around 7 seconds. And of course, the only one that came back with that timeout was 3389, which is a good indicator that terminal services is running on that machine. So, again, that tool is just more of a proof of concept tool. It's on our website as well to download along with the code if anybody's interested. So the last thing I want to talk about is secure bindings. And I know it's 2:50. How much time do we have left? 5 minutes? Okay. So the last scenario we'll talk about is secure bindings. I have a demo for this, but we probably won't do it, but I'll just sort of hit the relevant points here. The key about secure bindings is that they allow the communications to happen using WS security, which is the open security standards for web services. And the nice thing about this is it supports things like message signing, encryption, all sorts of good stuff. So when you're trying to communicate with an endpoint that uses message security, there's a couple things that are either going to prevent you from communicating with it at all, or potentially you'll still have some options. The first is figuring out what mode, what type of credentials the service requires. So you can see here it supports Windows credentials, a certificate, username, anonymous, or a token for some sort of federated model. The only two that you're going to really have any luck with here, if you don't have any business talking to this service, is going to be username, which is going to allow you to just do a brute force, or anonymous. And anonymous, unfortunately, is not as straightforward as one would think, because it actually requires a server certificate in order to do it. So it's very similar to SSL. The server has a certificate, you don't need one, but there's a negotiation that happens using that certificate. So the first thing you'll do is, if you can get some metadata, in the metadata, and I'll show you this, a screenshot here, you're going to look at the binding settings, and it's going to tell you the mode in which, the security mode in which the endpoint operates. It's either going to be transport mode, which just means SSL, message mode, which means there's going to be a client credential, and that's where it goes back to that Windows certificate, username, that type of thing. Or it's going to be transport with message, which means both, or none, in which case this is a non-issue. Now, in order to do this, if we think about the way message security works, it's specifically designed to prevent man-in-the-middle attacks. So an intercept proxy is really going to be pointless here, because the intercept proxy is just going to show you the different encrypted messages. So there's a couple tools that I've got up here that you can use that support message encryption. I believe the SOAPy tool as well supports it as well, and SOAP UI. But the WCF test client actually comes with Visual Studio. If you don't have Visual Studio, the client itself was bundled for free by some guy who has a blog on ASP.NET, so I've included the link there. And what it does is it provides a nice little GUI. I'll show it to you here real quick. It provides a nice little GUI that you can use to talk to any WCF endpoint. And for the most part, it supports all of the common bindings. So if I go ahead and launch it here, the first thing I'm going to do is I'm going to have to actually point it towards my service. And I've got a sample web service here that uses message encryption on our VM. So I'm going to go ahead and point it towards there. It's going to automatically try and get the WSDL. If there's some odd path to the metadata, you can specify it there, but it'll try $WSDL, it'll do a post MEX request. It'll pretty much do all of the common requests to get the metadata. And provided that it works, it's going to return a list of all the different accessible methods, and it's going to also give us the configuration, the binding options, and generate almost like a little config file for us, which is what I've got here in the screenshot. And if you can see it there, the part that we're most interested here is the security mode. So you can see here it's set to message, and then the client credential type under transport. Now, this is where it gets confusing. There's going to be a transport credential and a message credential. If transport is not enabled, so it's not transport mode, it's not message with transport, the settings in transport don't matter. So just because it says Windows is the client credentials type doesn't mean we need Windows credentials. It's the message credential that we need. And you can see there the type is none. So we know automatically that we're going to be able to talk to this web service. This is taking a little longer, so I'll just keep going. The other thing to keep in mind is that if you try to then connect to it, chances are, in a lot of scenarios, you're going to get a SOAP fault. And it's going to say that the security negotiation failed. And this is a very misleading error message. What's happening here is if you know it's using anonymous message encryption, the reason this negotiation is failing is probably because there's something wrong with the certificate. Just like I mentioned before, just like SSL, you need to have a certificate on the server to initiate this whole encryption process. And if it's not signed by a trusted CA, if it's not a valid certificate, this negotiation is going to fail. So luckily, if you go back, and this is a screenshot of the WCF test client, if you scroll down in the metadata somewhere or in the config that the metadata that the WCF client generates, you'll see there that under the client, the endpoint identity node, there's actually an encoded base64 encoded certificate. This is actually the public key, the public certificate that you need to have in your trusted people store in order to talk for this negotiation to not fail. So it's really as simple as just cutting and pasting this into a text file, naming it with a .cer extension, double-clicking it, importing it, and then the next thing you know, this error message is going to go away. So just because you get a negotiation fault does not actually mean that you don't have the right credential. It just means that something's failing. And unfortunately, the error messages are a bit generic, which I guess was probably the result of some security assessment that somebody did somewhere down the line, which makes it a little difficult to figure out what exactly is causing that failure to occur. It looks like this client is still generating, so we'll just sort of move on. That's actually a very good point. You're right. Burp has intercepted that request, which has caused our request to hang here. So I'll come back to that in a second and see if it's just a couple notes here. The other thing you want to do is if you're using an actual thick client and you're having problems with certificates, there's an option within the client config that you can put in here to disable certificate validation. Again, it's on by default, so you can just disable that, and then if there's any sort of problems with certificate validation, it's not going to be an issue. The other thing I mentioned is that aside from anonymous authentication or message encryption, there's also username and password-based encryption, which requires you to authenticate and then generates does a security negotiation based off that. The important point here is that it's simply just a plain text SOAP header. There's nothing magic about it. All of the SOAP utilities, for the most part, support this, and you can easily brute force this. It'll lock out, of course, depending on what they're using on the back end, but you can pass in a SOAP header. The only caveat here is that the framework will not allow this header if it's not going over SSL. So you need to be talking to the endpoint over SSL. Otherwise, this isn't going to work. So let me just try and add this service one more time here, and if it doesn't work, really the whole point of this demo was just to really show you what the communication looks like over the wire. You'll see that for any invoking even one method to do one operation on the web service actually causes on the back end a series of 4 or 5 different requests where this key negotiation occurs in order to do the whole message level encryption. So the last section I had on custom test clients, it's really not that important. The only takeaway here is that, if all else fails, you can always write your own test client. It's really as easy as you can do it in less than 10 lines of code. All you have to do is generate a stub to the web service using the metadata utility if you have the WSDL. And then even in that same class file, you just have to import the system namespace at the top and add a main routine to turn that class file into a console utility. And then you can run it from the command line. And this is an example of just sort of snapping a main method to the end of your interface class and converting that class into a console utility. So the long and short of it here is that all of the same attacks that have always applied, for the most part, are still very easily done with WCF. The real stumbling block is going to be these different formatting options and the different nuances that these bindings introduce. And certainly the tool set you're going to have at your disposal is limited, especially because a lot of these protocols are proprietary, but certainly not a hurdle you can't overcome. And I think as we start seeing more and more Silverlight adoption, you're just going to end up seeing a lot more of these WCF services on the back end, pushing all the data to these clients. So if anybody has any questions, I'll be around for a few minutes. We've also got all the tools that I talked about today are on our website. And if you have any questions, you can always email me at the email address above. All right, thanks.